Okay, for this problem, we're going to kind of do a little bit of some of the combination of things that are asked for in questions 11 and 12 in module 5. So kind of to cover some of those, basically I want to show you graphing, amplitude period, the phase shifts, as well as vertical shifts. Okay, so the first thing that we want to do is it's always important to graph the parent function. So in this case, the parent function is going to be y equals the cosine of x, right? And so that parent function is, when we're graphing that, is we're always up here at 0, 1, and then we'll be here at pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi will be back up here at 1. So if we're graphing that standard, that standard cosine graph, that is what cosine of x looks like. Okay, so those are the 5 major points: 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that helps us when we start looking at graphing these shifts. Okay, so the first thing I want to point out is we can pull these values. So a equals 1/2. Our b is the number in front of our x here, which is a 1. So our b is equal to 1. And because this isn't completely in standard form, if we were to write this in standard form, right? So this would be y equals 1/2 cosine x minus negative pi over 2, right? Because that standard form has this x minus here, right? And so again, just to put out here, we have that our a is equal to 1/2, b is equal to 1, and c is equal to this negative pi over 2. So if we pull all that out, it makes it a lot easier for us to just pick that information off over here on the side when we're looking for our amplitude, period, phase shift, and so on. Okay. So the other thing I will add real quick is this has right here is the +0 out to the end. A lot of books will call that D. So D is equal to 0 here. Okay. And so with that being said, our amplitude is the absolute value of A. So we're looking at, let's do a different color. The absolute value of 1/2 is 1/2. So that's going to be our amplitude for this graph. Okay. Our period is going to be 2 pi divided by b. Our b in this case is 1. So that's going to be 2 pi. Our phase shift is going to be our c, which is negative pi over 2 divided by b, which is 1. So our phase shift is negative pi over 2. And then our vertical shift is d. So let me write that here. That's d. And that in this one, we would say none because there is no vertical shift. That means this graph isn't shifted up or down by a specific amount. Okay. So the amplitude tells us that we're going to oscillate now between negative 1/2 and positive 1/2. So the graph that you see here on the blue graph, that's oscillating between 1 and -1 because that is the range of a standard cosine graph. But this one has that transformation. And so now we're going to oscillate between, this is positive 1/2 and this here is negative 1/2. Okay. We also have to shift, we have this phase shift of negative pi over 2. So that means we're going to shift to the negative direction, and we're going to we're going to shift in that direction. So we're going to take this first point and shift it negative pi over 2, right? But remember, we're not going to be oscillating between 1 and negative 1. We're going to be oscillating between negative 1/2. So we're going to come here to the 1/2. And now we just keep the same pattern. So at 0, we would be down here at the negative 1/2. At pi over 2, we would be, at 0, we'll be here at 0, 0. Then at the pi over 2, we'll be down here at negative 1/2. Then at pi, we will be back up here on 0. And at 3 pi over 2, we will be up here at the positive 1/2. So this graph kind of oscillates like this. And it doesn't have to be perfect on, but as long as you, especially for you all being able to select the graph out of Mobius, it is less, being able to calculate those points and know where those points are is going to be much more valuable.